Hello children. Today we come to the last part of electrolysis. Applications of electrolysis. Electroplating with metals, electrorefining of metals and electrometallurgy. These are three applications of electrolysis. First, electroplating. The process of deposition of a thin film of metal like gold, silver, nickel on another metallic article by electrolysis is called electroplating. Why do we do electroplating? For decoration purposes, I can electroplate a steel spoon with silver. Second, to protect from rusting or corrosion, I can electroplate my scissor with nickel to prevent corrosion. I hope you must have written the table on page 115. Electroplating an article with silver. Suppose I am electroplating my spoon with silver. You see, it will give an attractive appearance, a rich appearance. The electrolyte used, sodium argentocyanide, NaAgCN whole twice. At cathode, I will place the spoon. Anode will be a bar of pure silver. So during electrolysis, the overall dissociation equation, NaAgCN whole twice gives me Na plus Ag plus 2Cn minus 1. Remember your valencies and symbols. H2O gives me H plus and OH minus. Cations migrate to cathode. Na plus, Ag plus, H plus. Ag plus will be discharged because it lies below in the electrochemical series. At cathode, reduction occurs. Ag plus gains electron and gives me Ag. So silver is deposited on the spoon. Cn minus and OH minus both migrate towards anode, but none will be discharged because the anode is made up of silver, which is an active electrode. So the anode itself ionizes. Ag minus electron gives me Ag plus. So these ions will continue to enter into the electrolyte. Very important question. Why is silver nitrate not used as an electrolyte? Because the deposition of silver would be very fast and uneven. There would be an uneven coating of silver on the spoon. That is why you are not using silver nitrate. Now we will electroplate an article with nickel. Electrolyte, aqueous solution of nickel sulfate. At cathode, you have the article and anode will be a bar of pure nickel. Similarly, just like in silver, the overall dissociation equations. NiSO4 gives me Ni plus 2 plus SO4 minus 2. H2O gives me H plus OH minus. Cations migrate to cathode, anions migrate to anode. At cathode, reduction occurs. Ni plus 2 gains 2 electrons and nickel metal is deposited on the article. At anode, both SO4 minus 2 and OH minus will migrate, but none will be discharged because nickel is an active electrode. Hence, itself will ionize. Ni minus 2 electrons gives me Ni plus 2. So, the nickel ions will enter into the electrolyte. We come to the next application of electrolysis, which is electro-refining. We do electro-refining of copper. So for this, again, you will have to go back to electrolysis of aqueous copper sulfate using copper electrodes. The process of refining an impure metal to a pure metal by electrolysis. Electrolyte, a solution of copper sulfate and dilute sulfuric acid. Cathode, thin strip of pure copper, and anode is impure copper. Equations. CuSO4 gives me Cu plus 2 plus SO4 minus 2. H2O gives me H plus OH minus 1. So at cathode, you have learned this, children. Cu plus 2 electrons gives me Cu. It is deposited. At anode, itself ionizes to liberate Cu plus 2 ions, which will enter the electrolyte. The impurities will be left behind as anode mud. Name the metals which are refined by electrolysis. You have many examples here: zinc, lead, mercury, silver, copper, etc. Electrometallurgy. The process of extraction of metals by electrolysis. Extraction of metals. We will again come to this topic when I do chapter metallurgy. Metals which lie higher in the electrochemical series are extracted only by electrolysis, such as potassium, calcium, sodium, magnesium and aluminium. Why? Because they have a strong affinity for oxygen and their oxides are stable, so they cannot be reduced by carbon monoxide and hydrogen, but are only reduced by electrolysis. Reactive metals cannot be extracted from their aqueous salt solutions. Why? Because in aqueous state, H plus ion will be present along with the metal ion. And remember, H plus lies below in the electrochemical series. So at cathode, hydrogen gas would be liberated instead of the metal. Molten NaCl or fused NaCl. I am giving you one example here for electrometallurgy. NaCl dissociates to give me Na plus Cl minus. At cathode, Na plus electron gives me Na. Anode. Cl minus 1 will lose electron, become chlorine atom. Two chlorine atoms combine to give chlorine molecule. Greenish yellow gas would be liberated. With this, we come to the end of the chapter electrolysis. Children, learn again and again. I hope you must have done the back exercise and the ICSE questions. I will send you the self-analysis test on Monday. Start preparing. All the best.